According to the National Electrical Code Section 250.24b, where multiple grounding electrodes are used, they shall be bonded together to form a single grounding electrode system. It is unlikely that connecting the grounding systems of two services will violate utility regulations. Most utilities require a grounding electrode system for each service, but they do not typically prohibit bonding between grounding systems. A ground loop can occur when two separate grounding systems are connected together and there is a difference in potential between the two systems. This can cause current to flow through the ground loop, which can be hazardous. It is possible that there could be a potential difference between grounded equipment of the two services if they are not bonded together. This could occur due to differences in the grounding impedance of the two systems. The potential difference between grounded equipment can be a safety hazard. It can cause equipment to malfunction or damage, and it can also create shock hazards. Based on the NEC requirements and the potential safety hazards, it is recommended to bond the grounding systems of the two services together. This will minimize the potential difference between grounded equipment and ensure a safe electrical system. The bonding connection should be made using a copper conductor of sufficient size to carry the fault current. The bonding connection should be made as close as possible to the service entrance of each building. If the grounding electrode systems for the two services are located at different buildings, a grounding electrode conductor should be installed between the buildings to bond the two grounding systems together. When dealing with multiple services in a building, especially in a campus environment, it's critical to understand and address the grounding requirements outlined in the National Electrical Code, or NEC. The NEC provides specific guidelines to ensure safety and minimize potential hazards associated with the electrical systems. Let's delve into the key aspects of bonding multiple services and the associated considerations. The NEC mandates that where multiple grounding electrodes are present, they must be bonded together to form a unified grounding electrode system. This requirement is detailed in Section 250.24b of the NEC. The purpose of this provision is to create a common ground reference for all services within the building, which helps to equalize potential differences and reduce the risk of electrical shock or equipment damage. It's important to note that this requirement applies regardless of whether the services are supplying different voltage levels, such as 120/208 volts and 480 volts in the example. Concerns often arise regarding potential violations of utility regulations when connecting grounding systems of multiple services. However, it's generally unlikely that such connections would violate utility rules. In most cases, utilities require a grounding electrode system for each individual service to ensure proper grounding and safety. However, they typically do not prohibit bonding between these grounding systems. It's advisable to consult with the local utility company to confirm their specific requirements and policies regarding grounding and bonding of multiple services. Another concern that frequently arises is the possibility of creating a ground loop when connecting two separate grounding systems. A ground loop can occur when there is a difference in potential between the two grounding systems, causing current to flow through the interconnected ground path. This circulating current can be hazardous and can also interfere with sensitive electronic equipment. However, proper bonding techniques and adherence to NEC guidelines can minimize the risk of ground loops. By creating a low impedance path between the grounding systems, potential differences are minimized and the likelihood of circulating ground currents is reduced. It's essential to use appropriately sized conductors for bonding to ensure that the impedance of the ground path is sufficiently low. When multiple services are not properly bonded together, there is a risk of potential differences between grounded equipment connected to each service. This potential difference can arise due to variations in the grounding impedance of the separate systems. Even small differences in impedance can result in significant potential differences, particularly during fault conditions. These potential differences can create safety hazards, as individuals may be exposed to shock voltages when coming into contact with grounded equipment connected to different services. Additionally, potential differences can damage or malfunction equipment due to voltage stress and insulation breakdown. Given the NEC requirements and the potential safety hazards associated with unbonded services, it's highly recommended to bond the grounding systems of multiple services together. This bonding creates a common ground reference and minimizes potential differences between grounded equipment. By ensuring a low impedance path between the grounding systems, the risk of electrical shock and equipment damage is significantly reduced. The bonding connection should be made using a copper conductor of sufficient size to carry the anticipated fault current. The size of the conductor should be determined based on the requirements outlined in the NEC, considering the size of the service conductors and the available fault current. It's crucial to use a conductor that is adequately sized to safely carry fault currents without overheating or causing a fire hazard. The bonding connection should be made as close as possible to the service entrance of each building. This minimizes the impedance of the ground path and ensures that fault currents are effectively conducted back to the source. The connection should be made to the grounding electrode conductor or the main grounding busbar at the service entrance. If the grounding electrode systems for the two services are located in different buildings, a grounding electrode conductor should be installed between the buildings to bond the two grounding systems together. This conductor provides a continuous low impedance path between the buildings and ensures that the grounding systems are effectively interconnected. The size of the grounding electrode conductor should be determined based on the requirements outlined in the NEC. In summary, when dealing with multiple services in a building, it's essential to adhere to the NEC requirements for bonding grounding systems. By bonding the grounding systems together, you create a common ground reference, minimize potential differences between grounded equipment, and enhance the safety of the electrical system. Remember to use appropriately sized conductors, make connections as close as possible to the service entrance, and install a grounding electrode conductor between buildings if necessary. Consulting with a qualified electrical engineer or contractor is highly recommended to ensure compliance with all applicable codes and regulations. They can assess the specific requirements of your building and design a grounding system that meets your needs. The NEC provides additional guidance on grounding and bonding requirements in Article 250. This article covers a wide range of topics, including grounding electrode systems, equipment grounding, and bonding of metal enclosures. It's crucial to familiarize yourself with the relevant sections of Article 250 to ensure that your grounding system complies with the NEC requirements. When selecting grounding electrodes, it's important to consider the soil conditions and the available space. Common types of grounding electrodes include ground rods, ground plates, and underground metallic water pipes. The NEC specifies the minimum size and installation requirements for each type of grounding electrode. The number and spacing of grounding electrodes may also be specified by the NEC depending on the soil resistivity. The grounding electrode conductor connects the grounding electrode to the grounding busbar in the service equipment. The size of the grounding electrode conductor is determined based on the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor for various service conductor sizes. Equipment grounding conductors provide a path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. Equipment grounding conductors are typically installed in the same raceway or cable as the circuit conductors. The size of the equipment grounding conductor is determined based on the size of the overcurrent protection device protecting the circuit. Bonding jumpers are used to connect metal enclosures, such as electrical boxes and cabinets, to the grounding system. Bonding jumpers ensure that all metal parts are at the same potential, reducing the risk of electrical shock. The size of the bonding jumper is determined based on the size of the circuit conductors. The NEC also provides requirements for grounding sensitive electronic equipment, such as computers and medical equipment. These requirements are designed to minimize electrical noise and interference, ensuring proper operation of the equipment. Isolated ground receptacles are often used for sensitive electronic equipment. These receptacles have a separate grounding conductor that is isolated from the building's normal grounding system. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other transient events. SPD are typically installed at the service entrance and at downstream panels. The NEC provides requirements for the installation and wiring of SPD. Regular inspections and testing of the grounding system are essential to ensure its effectiveness. Ground resistance testing can be used to measure the resistance of the grounding electrode system. Visual inspections can be used to identify any damaged or corroded component. By following the NEC requirements and best practices for grounding and bonding, you can create a safe and reliable electrical system. It's important to consult with a qualified electrical professional to ensure that your grounding system is properly designed and installed. This is very important for educational buildings and campuses, as there will be many students coming into contact with all sorts of equipment. Maintaining the grounds is important so there isn't accidental damage to the grounding system. This includes making sure that when work is being done that the grounding system is not damaged. When there are lightning strikes, be sure that it is verified that no components have been damaged. Lightning strikes can be a real issue, and it is wise to perform infrared scans on electrical systems to verify their integrity. Always keep safety in mind and stay informed about electrical topics like these. Remember that electrical codes are often updated, and it is up to you to follow the latest revisions. This will ensure that people are safe. This also means it is up to the facility managers to maintain the electrical systems. Grounding systems need to be verified periodically to ensure safety. The NEC is updated every 3 years, and it is very important to understand the latest version. Each update will add new rules or change old rules, so there is an understanding of all of the requirements for safety. Bonding and grounding are very important for safety, and it is often a good idea to hire a professional to assess the electrical system and provide an opinion. There may be other conditions present that need to be corrected for safety. There also may be items that need to be corrected for compliance. When dealing with 480-volt systems, it is very important to follow all safety precautions. Electricity can be very dangerous. Qualified personnel should be performing electrical work. The facilities department should have a plan for all electrical upgrades and repairs. They should also have a budget in place. This will ensure that everything is done correctly and safely. Another consideration is arc flash protection. Arc flash events are dangerous, and steps need to be taken to protect workers from these events. There are several ways to reduce the risk of arc flash events. One way is to use arc flash rated equipment. Another way is to de-energize equipment before working on it. It is important to follow all safety procedures when working on electrical equipment. Training is another item that is important. Training can help workers to understand the risks of electrical work and how to stay safe. A facilities department needs to be well versed in the electrical field. They should have the experience to know what to do. When they don't have the experience, then it is up to them to hire a qualified electrical contractor. This will ensure that everything is done correctly and safely. There should be meetings between the facilities department and electrical contractors to discuss electrical safety. This will help to keep everyone on the same page and ensure that everyone understands the risks of electrical work. There should also be regular safety audits to identify any potential hazards. This will help to prevent accidents from happening. It is important to create a culture of safety in the workplace. This means that everyone is responsible for safety. If someone sees something that is unsafe, they should report it. This will help to keep everyone safe. Remember, there are different types of grounding systems. Grounding systems are very important. It is also very important to consider how the electrical systems are designed. In older buildings, the electrical systems may not meet current standards. It is up to the facilities department to bring these systems up to code. This can be a very expensive project. It is important to budget accordingly. There are also grants available to help with electrical upgrades. It is important to do your research and find out what grants are available. Electrical safety is everyone's responsibility. The goal is to make sure everyone gets home safely. When dealing with electrical systems, remember the basics and be careful. Electrical systems can be very dangerous. Always follow safety procedures. The facilities department plays a very important role in electrical safety. They are responsible for maintaining the electrical systems and ensuring that they are safe. They should also have a plan for electrical upgrades and repairs.